All right, let's talk about something huge that's happening right now in the world of technology. It's being called China's Manhattan Project for the 21st century. We're talking about an all-out race to control the future, and it all kicks off in a top-secret lab in Shenzhen. And the language being used to describe this effort is, well, it's pretty intense. I mean, just think about that for a second. The Manhattan Project. That's not a term you just throw around lightly. It tells you that for China, this is a matter of national survival, a mission to break free from depending on Western tech. This goes way beyond just making a better phone chip. This is about trying to completely redraw the global map of power and innovation.
So, that's the big question, right? What does it actually take to win a technological race of this magnitude in our crazy, interconnected world? It's not as simple as just throwing a ton of money and brilliant engineers at the problem. As we're about to find out, it means mastering some of the most complex physics on the planet, navigating a tangled web of global economics, and playing a decades-long game of catch-up. So, let's break it down.
First up, let's get into the news that really set this whole thing off.
Here's the headline. Chinese scientists have successfully built a working prototype of something called an EUV lithography machine. Now, what is that? Just think of it as the most advanced printing press ever created. It uses extreme ultraviolet light to etch circuits so tiny you can't even fathom it. This is the absolute key, the one technology you have to build the world's most powerful chips, the ones that are going to run everything from your next smartphone to the future of artificial intelligence.
And we're not talking about some small lab experiment here. This thing is massive. It takes up an entire factory floor. The reports say it was built by reverse engineering existing tech from the Dutch company ASML, who are the undisputed kings of this field. So you're essentially taking apart the world's most complex machine to figure out how to build your own. It's an absolutely monumental task. And right now, that prototype is being put through its paces to see if it can really hold up. But of course, something like this doesn't just happen in a vacuum. Let's look at the mission behind the machine.
This is a full-on top-down national priority. You've got the highest levels of government involved, with the tech giant Huawei running the show. We're talking about thousands of engineers working across the country in secret, isolated teams. The pressure is so intense, people are reportedly sleeping on site. It just shows you how incredibly serious China is about cracking this technological nut.
Okay, let's dive a little deeper into the technology itself. What exactly did they build? And, how does it really stack up against the competition?
So, as we said, EUV lithography is basically the magic wand of modern computing. It's all about using these incredibly precise beams of light to draw circuits thousands of times thinner than a human hair. Mastering this process isn't just important, it's the single biggest barrier to entry for making the next generation of super powerful chips.
And this is where you really see the scale of the challenge. On one side, you have China's prototype. It's huge, it's reverse engineered, and it's still pretty crude, a first draft. On the other side, you have ASML's machine. It's the product of decades of optimization and R&D, and it's the undisputed global standard. It's a classic David versus Goliath story, playing out in the world of high-tech manufacturing.
And getting into that Goliath's league comes with a jaw-dropping price tag. A single one of ASML's commercial machines costs $250 million. The amount of capital you need just to get in the game is absolutely astronomical.
But here's the real kicker. Money isn't enough. You can't just buy your way to the top. ASML's dominance comes from a journey that took almost 20 years, billions in research, and, this part is absolutely crucial, a global network of partners. They rely on specialized suppliers from all over the world, an ecosystem that no single country can just replicate overnight. You can't reverse engineer an entire global supply chain.
And that global network is the perfect way to get into the economics of all this. To really understand the mountain China is trying to climb, we've got to look at the incredibly complex industry that supports all this. And we can do that by looking at a key supplier company called Photronics.
So, take a look at this. It tells you pretty much everything you need to know. Photronics is an American company, but a whopping 83% of its revenue comes from outside the US. Why? Because the entire chip industry is this finely tuned global machine. You've got raw materials from one country, design software from another, and final assembly somewhere else entirely. It's what makes the industry so efficient, but it also makes it incredibly hard to go it alone.
Now, within that global machine, the power dynamics are wild. For a key supplier like Photronics, just 5 major customers
Account for half of their total revenue. I mean, think about that. Half. That is an insane level of concentration. It means that just a tiny handful of giant companies hold enormous power, and the whole system is vulnerable if something happens to one of those key relationships. We're talking about the strategic choke points of the entire tech world.
So what's the takeaway here? The global chip industry is basically a high-wire act. You've got companies that are totally dependent on just a few suppliers. You have geopolitical tensions that could snap a supply chain in a heartbeat. The loss of just one big customer could be a catastrophe. And on top of all that, you have these multi-billion-dollar factories that have to run 24/7 just to be profitable. It is an incredibly fragile and complex system, and that's the world China is trying to break in.
Okay, so let's pull all these different threads together. What does this new prototype really mean for the future of the chip race?
Well, here's the bottom line. Building a working prototype is a huge scientific achievement, no question about it. It's a massive step. But it's only the first step on a very, very long road. Sources close to the project are saying China is still years, maybe many years, away from being able to mass-produce chips that can truly compete on a commercial scale. The race isn't over. In a lot of ways, it's really just getting started.
And all of this leaves us with the ultimate question, doesn't it? Can sheer national will, a top-down mission with massive investment, actually replicate what took the rest of the world decades of global collaboration and messy, market-driven innovation to create? China is betting everything that it can. The rest of the world is holding its breath to see if they're right. And the answer is going to define the future of technology for all of us.